In the previous video, we discussed one method for solving linear equations, which is the substitution method. Another way to do systems of equations is called the addition method. In the addition method, we want to make sure that we write both equations as ax plus by equals c, meaning we want to get our x and our y on the same side of the equal sign. Then we create opposite coefficients for one variable by multiplying one equation by a number. We may even have to multiply both equations by a number to make them opposite, meaning one has a positive 5, one has a negative 5, that type thing. Then we add and solve for one variable. Again, the same thing that we did in substitution. We have to substitute that one variable back into the original equation for the other value so that we can find it. Okay? So let's look at the same system of equations. 2x plus 3y is equal to 10, and 5x minus y is equal to negative 26. Notice I already have x's lined up and y's lined up on the same side of the equal sign. So what I want to do is I either want to make the x's the same number, just opposite signs, or I want to make the y's the same number, opposite signs. In this case, it is going to be much easier to make the y's the same number, opposite signs, because notice I can multiply the top equation by a 1 and the bottom equation by a 3. When I do that, I end up with 2x plus 3y is equal to 10. Notice it didn't change a thing because I just multiplied it by 1. Then I'm going to multiply all of these by a 3, giving me 15x minus 3y is equal to a negative 78. Now notice how my y's are the opposite number. They're both the same number, just opposite signs. So what I'm going to do is I'm going to add these two equations together so these cancel out, leaving me with 2 plus 15 is 17x equals a 10 minus 78 gives me a negative 68. Now I only have one variable, so I can now divide both sides by 17 and get that x is equal to a negative 4. What I'm going to do is I'm going to plug this negative 4 in for the x of either one of these original equations. It doesn't matter which one I do. So let's just say that I take the top equation, 2x plus 3y is equal to 10. Plug in the negative 4 for my x, and then I'm going to solve for my y. So I've got 2 times negative 4 plus 3y is equal to 10. Well, 2 times negative 4 is a negative 8 plus 3y is equal to 10. I've got to get y by itself, so I'm going to add 8 to both sides. So that's going to give me that I have 3y, because these cancel out, is equal to 18. Divide both sides by that 3 so that we get y is equal to 6. So this shows me that negative 4, 6 is a solution. Now notice I plugged in the negative 4 for the first equation. I could have plugged it in for the second equation. So it could have been in this equation, 5x minus y is equal to a negative 26. And where I plug it in, I get 5 times a negative 4 minus y is equal to a negative 26. So 5 times negative 4 is negative 20. Minus y is equal to a negative 26. I will add 20 to both sides because I'm trying to get that y by itself. This is going to leave me with a negative y is equal to a negative 6. Now notice they're opposite signs, but my y is also opposite. So I still have to divide by a -1, which will then give me that y is equal to a +6. It didn't matter which equation, which original equation I plugged that -4 in for. I could plug it into either one and I get the same y. So try a few examples with addition, and if you need help, let me know.